This is lesson 5.1, graphs of quadratic functions. We have two goals. The first one is mainly a refresher from Algebra 1. I can identify key characteristics of parabolas given a graph. And then the second one is more Algebra 2-ish, so I can identify key characteristics and graph parabolas given an equation in any form. So we're going to look at three forms today. We've got standard form, vertex form, and factored form. Factored form is also called intercept form, so that's maybe something you want to know in case you see that word instead, intercept form. And each one just tells us something unique. So we're going to look at what's unique about each one, and then we're going to look at how we can graph a parabola given that information. So let's move on here. And first, graphs of quadratic functions, just knowing the parts of a parabola. So the vertex is simply the highest, lowest point on the graph. You can see here the vertex on this particular parabola is positive 1, negative 4. Highest point is often called the maximum point, and then the lowest point is called the min. So they'll ask if the parabola has a max or a min. Y-intercept is simply where it crosses the y-axis, and you can see there that it looks like it crosses at negative 3. So we'd say negative 3 is the y-intercept. The x-intercept's where it crosses the x-axis. For this particular parabola, it's negative 1 and 3, but I want to remind you that you may have no x-intercepts, and if that's true, that means your discriminant on the quadratic function is equal to a negative value, and that's what results in no x-intercepts. And we would see this parabola opening up and floating above the x-axis, or opening down and floating down below the x-axis. So if it has one x-intercept, that would mean the discriminant was equal to 0. And that when you add or subtract negative b plus or minus 0, you're going to get the same value. So you're going to get the same root twice. Or, like we have in this example, we have two roots, and sometimes those roots are rational, meaning I can express them as a fraction, and sometimes they're irrational, where they don't have a specific value. So also know that roots or solutions or zeros and x-intercepts all mean the same thing. All those are the same, refer to the same thing, okay? Just different, we talk about roots of an equation or a quadratic function, or solutions to a quadratic function, or zeros, because that's where it crosses the x-axis, and y is 0 there, and x-intercepts because that's where it crosses through the x-axis. So last piece of information is the axis of symmetry, and it's just a vertical line that acts as a mirror of the left and the right halves of the parabola. They are mirror images of each other. If you plot a point on one side, you can plot a matching point on the others. And this particular axis has the equation x equals 1. It's just going to be x equals every time, a vertical line, and it's going to be the value of the vertex. The x-coordinate of the vertex is the value it's equal to. So in this case, x equals 1. So just looking at an example then of getting, practicing naming those parts. So the vertex here is this point right there at the top. This one opens down, so it's got a maximum point at the vertex, and that's negative 3 on the x and positive 1 on the y. The y-intercept is down here at negative 8, or they could ask you to put it in ordered pairs, so 0, negative 8, because for y-intercepts, x is 0. The x-intercepts are negative 4 and negative 2, or we can put them as ordered pairs, negative 4, 0, and negative 2, 0, if they ask for the coordinates. And then the axis of symmetry would be x equals negative 3. We would put a dotted line just down through the vertex there, and that would give us an equation of x equals, and the x-coordinate of the vertex is negative 3. All right, you guys give this one a try. Stop the video when you're done, or stop the video and try the problem, and then start it back up again. All right, this time the parabola opens up. We've got a vertex at negative 3, negative 4. The y-intercept is at 5. The x-intercepts are negative 5 and negative 1, and the axis of symmetry is x equals negative 3. All right, let's talk about the three different forms of a quadratic. So we've got a standard form, which you should be familiar with, because anytime we solve a quadratic in using quadratic formula or factoring, we put everything on one side of the equal sign. And so this A, B, and C that you're seeing are exactly the same as what we studied when we did the quadratic formula. Vertex, and what's the piece of information that the standard form gives you is the y-intercept, the C value. And it doesn't matter, what the polynomial is or how many terms it has. The constant without the variable x is always going to be the y-intercept. Because if you put 0 in for all the other x's, the only thing that's left would be the constant term. So that's the y-intercept. Vertex form, hopefully you realize if it's called vertex form, it gives us the vertex. So there's going to be a number here and a number here, and that ordered pair would make the vertex. But you need to remember that it's going to be the opposite of what it looks like the h value is, but the k value is just what it says there. It's going to be either positive, you say positive. If it's minus, you're saying negative. And we'll talk about that in a little bit. And the third one's intercept form, which it looks like someone has factored a polynomial, like they pulled out a GCF of a, and then they factored this into x minus p and x minus q. So that looks very similar to that, and that's why we often call this factored form as well. Okay, so intercept and factored form mean the same, and it gives you the two x-intercepts in this case, if there are two, or solutions or roots, as you know. So p and q are the roots then, or you could write them as ordered pairs with y being 0. So let's look at these more closely. So here's standard form. Once again, it gives you the y-intercept, which is just the c value. The a value in every form tells you the same thing. It tells you the direction the parabola opens. If it's positive a, it opens up, and if it's at negative a, it opens down. And the other thing I'll tell you about the a value is if you have a large a value, it's going to be a narrow, steep graph. And if you have a small, and I'm just talking magnitude here, not sign. The sign just tells you up or down. If you have a small a value, it's going to be wide, like a smiley face. And it could open up and it could open down. That's what the sign on the a tells us. But the magnitude of a tells us how steep it is, kind of like slope. The vertex, we've got to figure out the vertex. And if you look here at this little formula that you're going to use to figure out x, it looks very similar to the quadratic formula. It's the opposite of b over 2a piece there, okay? And that should give you the vertex x coordinate. Then plug that back into the original equation and you'll find y. The axis of symmetry then is just x equals the x coordinate that you just found from above. And the x-intercepts, you'll have to solve the equation using factoring or QF like we did this past unit, okay? So, standard form. I'm just going to go with what the equation tells us right off the bat first. So this equation being in standard form tells us the y-intercept is 6. So I'm going to go over here and I'm going to plot 6. Well, then the a value is... it's a negative a, so this is going to open down, okay? The third thing I want is the vertex. The vertex is an ordered pair, x and y, and to get the x, we say negative b over 2a is the value of x, or opposite of b. So the opposite of b would be negative 4 over 2, and a is negative 2. And so this is negative 4 over negative 4, 1. And then just plug 1 back into the original equation to get the y. So y is going to be negative 2 times 1 squared plus 4 times 1 plus 6. And this is going to be negative 2 plus 4 plus 6. So that's 8. So I'm going to plot my vertex at 1, 8 right there. And then the next thing I'm going to do once I get my vertex is I'm going to be able to write my axis of symmetry, which is x equals 1, the x coordinate of the vertex. And I just do a dotted line right down through there. And if you look at the graph now, I've got that y-intercept at 6. It's 1 unit to the left. The mirror image for that point would be 1 unit to the right. So our goal here is to plot 5 points. So you can see now what we have. We have the vertex is 1, the y-intercept is 2, but its mirror image is 3. So we just need 2 more points, and we want the x-intercepts. We want the solutions to this. So we've got y, or I'm going to set this equal to 0 to solve. 0 equals negative 2x squared plus 4x, that's a 4, plus 6, and I'm going to factor out a negative 2. And then I'm going to break that down into x minus 3 and x. Factor that into 3 and 1. So my x-intercepts are 3 and negative 1. Let's see how that looks on the graph. Here's 3, and here's negative 1. And hey, those are symmetrical with respect to the axis of symmetry. So there's my 5 points. So I just carefully draw this, not a shark's tooth, but kind of a rounded parabola at the end there, okay? And that's our parabola. So you guys give this one a try. Shut the video off, give it a try, and then start it back up again. So I got a y-intercept of negative 16. The a value tells me it opens down. The vertex starts with 10 over negative 2 or negative 5. The y-coordinate of the vertex, you got to be careful with this one. So negative, and then x is negative 5 squared minus 10 times negative 5 minus 16. So this negative 5 squared is 25, but then the negative hasn't, now we apply the negative on the outside to that, okay? And then negative 10 times negative 5 is positive 50 minus 16. So that's 25, 35, so negative 41 and positive 50 gives me a y-coordinate of 9. For AOS, x equals negative 5. Let's plot some stuff. So negative 16, oh, can't plot it. It's off my graph. This is off the graph. So I'll have to come up with some other points then, won't I? Okay. So vertex, negative 5, 9 is right there. That's good. Dotted line down through there. Okay. And let's find our x-intercepts. So we're going to say x, so 0 equals negative x squared minus 10x minus 16. I'll factor out a negative 1. And that makes this easy to factor. X and x, 8 and 2, both positive, making my x-intercepts negative 8 and negative 2. So negative 8, 6, 7, 8, and negative 1, 2, negative 2. So they're mirror images, very nice. And so I just need 2 more points. And so what I can do is I'll just pick an x value, but I'm going to pick one that's very close to the axis of symmetry. So like I'm going to pick the value of negative 4 and just plug that back into the equation. So I'm going to choose x equal negative 4. And then I'm going to go y equals negative of negative 4 squared minus 10 times negative 4 minus 16. So let's see what y is. So I'm choosing an x value that I haven't plotted a point for yet. Right, somewhere close to the axis of symmetry. I could have put negative 3 in. I could have put in negative 6. I could have put in negative 7. It doesn't matter. You just need another point on the line. So this is going to be negative 16 plus 40 minus 16. So that's negative 32 and positive 40 makes 8. So negative 4, 8 is another point on the graph. So I'm going to go to negative 4 and then up here to 8. And its mirror images over here. And that finishes my 5 points very nicely. And I get my parabola. Okay? So if there's a point you can't plot and you need another point, just pick an x value and plug it in. but stay close to the axis of symmetry with it. Don't put in like 10, because 10 is going to give you an extremely negative value that's going to be off the bottom of the graph. So you just need to be wise on how you choose your x values. Just one right around the axis of symmetry, okay? All right, vertex form. So this form gives the vertex. The vertex is h and k. What you need to remember is it's really the opposite of h and then k, all right? So opposite of h, because that minus sign is part of the formula. So if I said h was 3, the formula would read x minus 3. But if I said h was negative 3, it would be x plus 3 if you plug negative 3 in there for h, because the minus and the negative on the 3 would make a plus sign. So it looks like h is opposite. So the a value, again, just tells us the direction. The graph opens either positive a is up, negative a is down. Y-intercept, plug in 0 for x. Axis of symmetry, we already know the x value of the vertex is h, so we'll just x equals that number. And then x-intercepts, plug in 0 for y, and this time we'll end up solving using square roots. So some of the early equations that we solved in the last unit look just like the vertex form, where we have to isolate the squared portion and then take the square root, and we'll do that. All right, so looking at this one, I'm going to always start with what the form tells us. In this case, it's in vertex form, so the vertex is negative 1, 7. So it looks like plus 1 is h, but really it's opposite. So it's negative 1, but you follow the rule with k. If it says plus 7, keep it plus 7. If it says minus 7, keep it minus 7. So negative 1, 7 is right here. Step 2, a is positive, so this opens up. Oop, I'm not doing 2 again. 3. Let's find the y-intercept. So we're going to put 0 in for x. So y equals 8 times 0 plus 1 squared plus 7. Well, that's just 0 plus 1 is 1. 1 squared is 1. 1 times 8 is 8. 8 plus 7 makes 15. So the y-intercept is up here at 15. And our AOS is negative 1. Like that. And then mirror image that y value, that y-intercept over there on the other side. And now, does anybody see an issue with this parabola? Hopefully you do. Hopefully you're like, well, this parabola opens up and it's totally above the x-axis. There are going to be no x-intercepts. None. Because it's floating above the x-axis. The x-axis is down here. So I don't even think I could plot another pair of points. I mean, I could choose maybe x equals 1, but I think if I chose x equals 1, I'd be off the graph. It'd be the y value would throw that value way up, because I'm already at 15 with the y-intercept. So I can't even plot 5 good points here. I'm going to have to just go with 3. Now, in the homework in Delta Math, you'll be able to plot 5 for every one of the questions, but I just wanted to show you that sometimes we can't get 5 on the graph, or we can't plot x-intercepts because they don't exist. If we put that equal to 0, let's see what happens. So we're going to do 0 equals 8 times x plus 1 squared plus 7. So I subtract 7. That's very sloppy. Subtract 7, divide by 8, and I'm ready to take the square root to get rid of my square, and look what happens. I am square rooting a negative right there. This is complex. And I can't graph complex roots because I'm not on a complex plane. Okay, complex plane would have an x-axis and then a complex y-axis with an I instead of y-axis. Okay, you guys give this one a try. This one will work out nice for you. Stop the video and start it back up when you're finished. So we got a vertex at negative 2, 4, negative 2, 1, 2, 3, 4. And then I've got an a value that's negative. So this is going to open down. So it looks like it'll hit the x-axis. That's good. 3, let's find the y-intercept. And it doesn't matter what order you find these things. You could find the zeros now if you wanted the x-intercepts. It doesn't really matter. I'm just kind of following the pattern I had on the slide, the steps. So y-intercept is 0 for x, so we're going to go with y equal -2, 0 plus 2 squared plus 4. So that's going to give me 2 squared is 4. And then 4 times -2 is -8. -8 plus 4 is -4. So y-intercept at -4. Our AOS, axis of symmetry, is x equals -2. So here at -2, and for that -2, I can mirror now my y-intercept, 2 units to the right, bounce 2 units to the left, and then I just need my x-intercepts. So set y equal to 0 this time. Subtract 4, divide -2, and we get 2 equals x plus 2 squared. And now square root both sides. So I get a positive -√2 equals x plus 2, and then subtract 2 to the other side. And so when you type those into the calculator, -2 plus √2, you're going to get an answer of -0.6. And when you do -2 minus √2, you're going to get a -3.4. So those are on the x-axis. So these are irrational. So we're going to do our best to plot them. So -0.6, I'll say, is about there. -1, -2, -3.4 is about right there. And that looks like it finishes our parabola nicely, right? We get 5 good points on there, and I'm going to draw my curve. And there's the parabola. All right, there's one more. That's intercept form. And this one's going to give us our x-intercepts, our solutions, or our roots, like someone has already factored for you. You certainly wouldn't want to multiply it back out if it's already factored for you. It's going to give you those 2 roots. A value tells you up or down again. Vertex, you have the x-intercepts, and the vertex has to be halfway in between them, so we can just average those x-intercepts and plug that x value back into the equation to get y. So you just add them and divide by 2. Axis of symmetry, x is just equal to the x-coordinate of the vertex that we just found, and the y-intercept, you plug in 0 for x. So let's look at an example of this one. So we'll start with what we know. So this one is telling me the x-intercepts are -2 and -6. So -2 and -6. And so what's halfway between -2 and -6? Well, hopefully you realize it's -4. So the axis of symmetry goes right down through there like that. And so I'm going to write here to the vertex. If I take -2 plus -6, here, let me write this here for you. Hang on. X is -2 plus -6 over 2, which is -4. And then we just plug that back in to get y. So y is 2 times -4 plus 2 times -4 plus 6. So that would be 2 times -2 times 2, which is -8. So my vertex is -4, -8. So -4, -8 brings me down here. Oops, it disappeared on me. And then I need the y-intercept. So let's figure the y-intercept out. Well, I guess we could write our AOS. Even though we plotted it already, it's x equals -2. I'm sorry, it's x equals -4. Okay. And then the a value is positive. I kind of skipped that step. A value is positive. It opens up. And let's find our y-intercept. So y-intercept. So y equals 2 times 0 plus 2 times 0 plus 6. Well, that's 2 times 6, which is 24. And that's off my graph. I'm not going to see 24, so I can't plot that on this graph. Right? Not enough space. So I pick a value. What value should I choose for x to plug in and get another ordered pair? Well, if I just go to either side of the x, the axis of symmetry is at -4, so I'm just going to go over here to -3, and I'm going to plot or plug in -3 for x. So if I make x -3, what's that make y? So 2 and -3 plus 2 and -3 plus 6 gives me 2 times -1 times 3, which is -6. So -3, -6 is another point on the graph. So -3 and then -6, and its mirror image finishes our parabola for us and gives us 5 good points. Okay. Let you guys stop the video, give this one a try, and turn it back on when you're done. So x-intercepts are 3 and -1. 3 and -1. I'll do A this time. Positive A opens up. Vertex. Halfway between 3 and -1. So 3 plus -1 over 2 is 1. So let's plug 1 back in for x. And I get 3 times -2 times 2, which is -12. So my vertex is 1, -12. Oh, wow. That's way down here. I had to kind of add a space there on the end, didn't I? All right, so now our AOS, x equals 1, is right here. It looks like we've got our x-intercepts, we've got our vertex. It looks like we just need our y-intercept. So 5 y-intercepts. Well, that's x is 0. So y equals 3 times 0 minus 3 times 0 plus 1. That's going to be 3 times -3 times 1, which is -9. So the the y-intercept is -9. And its mirror image, and that finishes that parabola. Like that. Okay. Last thing is increasing, decreasing, and positive and negative. So when we say where is something increasing or decreasing, we're referring to the y values. But we want to know on what interval of x is the graph increasing or decreasing, or are the y values increasing or decreasing? So we're looking to answer this with an interval that's on the x-axis as to where the y values are increasing or decreasing, or where the y values are positive or negative, okay? So pretend you're on a roller coaster and you're moving right to left or left to right, okay? And you're going, in this case, downhill. So the y values are decreasing, and they are decreasing from here all the way to here. And so in this area, I see the graph as decreasing. The y value is decreasing, okay? So how do you write that for x? So on the x-axis, the arrowhead is always infinity. So this is starting at to the left on the x-axis at -infinity. And you can't include -infinity, so I use a parenthesis. And then it's decreasing until we get to -3 on the x-axis. So at -3, I'm no longer decreasing. And at -3, the graph is neither increasing or decreasing. It's neither one, so we can't include it in the decreasing values, okay, or in that interval. Well, then what happens once it makes the turn? Well, it makes the turn at -3, so slightly more than -3. It's going to make the turn, and it's going to start increasing again. So in this section of the graph right here, right there, my graph is increasing. So that's from -3 out to, this again, arrowhead on the end, means it's going to go out to infinity in the x direction. Okay? All right, let's talk about positive, negative. Well, the y values are positive above the x-axis. So the first section that the graph that we encounter on the graph is this section right here. And we say that that graph is positive. Well, I did a very poor job on that. The graph is positive in this section right here, right? Like that. Oh, well, I got a funky looking rectangle there now, didn't I? So that's where the graph is positive, but it's also positive over here on the graph, right? And then where's it negative? Well, it's negative. Y values are negative down here. Okay? So I need to write my positive intervals, and just remember you're looking from left to right. So starting on the left, I've got an arrowhead on the left, and that's a symbol for negative infinity. Left on the x-axis is negative. And then it's going to continue being positive until it gets over there to -5, which I've kind of covered up now with my boxes. But then there's another section that's positive. So I'm going to do a union with this capital U here, which means to join two things together. And so it starts becoming positive again at -1 and continues being positive out to infinity in the x direction. Now notice, again, we didn't include any of these values because with brackets we used parentheses because at -5 the y value is 0, and that's not positive and it's not negative. So we can't include that. Same thing at -1. Now, where is the graph negative? Well, it's negative on the interval from -5 to -1. So in between those two, we see our graph is negative. Okay? You guys stop the video and give this one a try. Let's see how you do. So increasing would be from -infinity until you get to -3. And then it's decreasing from -3 to infinity. Positive. Well, there's only one section where it's positive, and that's from -4 to -2. But two sections where it's negative. -infinity to -4, unioned with -2 to positive infinity. Okay? All right. This assignment, you're going to see some questions about features of a parabola, a value opening up or down. Just remember that the a value, when it's large, it's steeper graph, and when it's small, it's going to be a wide open graph, like a smile face. Positive a up, negative a down. You're just going to match some a values with graphs on that. Here's standard form graphing. This one's going to ask you for axis of symmetry or the vertex. So you're looking for the x-coordinate first. If it's axis of symmetry, it's just x equals that number. But if it's the vertex, you'll plug it back in and get the y value to go with that. I didn't write the word vertex correctly, did I? Vertex, there we go. And then there's the three parabolas forms that we graphed. And then this last one asks you to select a form to use to find specific information. So if you want to know what the vertex is, what form do you want to see? Well, you want to see the vertex form. If you want the x-intercepts, what form do you want to see? You want to see intercept form, so on and so forth. All right, try those problems.